Welcome to this video where we'll explore an essential tool for project planning, the Gantt chart. You've probably heard the term Gantt before or seen this type of bar chart. But what exactly is a Gantt chart, and how can it help you plan your project in a logical timeline? That's exactly what we're going to explain to you. Originally, the Gantt chart was developed around 1900 by the American engineer Henry Lawrence Gantt to structure project activities over time. Think of it this way. Each activity in your project is represented as a horizontal bar on a timeline. The longer the bar, the longer the activity takes. The start and end points of the bar indicate when the activity begins and when it is expected to be completed. There are certain standards for creating Gantt charts that have become established in project management. All of them recommend visualizing project activities as a bar chart or Gantt chart. But what specific rules should you follow? In general, project activities can be categorized as follows. Activities with a duration are represented as bars. Events known as milestones are displayed as diamonds. Multiple activities and milestones can be grouped under a summary activity. This is what a simple Gantt chart might look like. 5 activities, a milestone, and everything grouped under a summary activity. What's still missing are possible dependencies between the activities to visualize their logical sequence. Because right now, all activities are happening at the same time. To achieve this, activities are linked together, represented by arrows. The purpose of linking is to show dependencies. For example, that activity 1 must be completed before activity 2 can start. This is the simplest type of dependency and is called a finish-to-start relationship, also known as a normal dependency. When we link all our Gantt plan elements using this normal dependency, we create what is known as a waterfall model. In this setup, each activity, whether an activity or a milestone, follows the next in sequence with no overlaps. An example of this is the sequence of production or construction processes. Simply put, the foundation of a house must first be excavated before it can be poured with cement. The cement must dry before the walls can be built on top of it. Of course, there are other types of dependencies as well. We'll take a closer look at them in the next video where we'll also explain terms like predecessor, successor, lag time, and buffer time. Until then, happy planning. For more guides, feel free to visit our website at InLoox.com or check out our video tutorials on YouTube.